Inverter.
Welcome to clickmyproject.com. We discussed about the process clustering based discriminant analysis for eye detection. In this paper we have to overcomes the problems on visual linear discriminant in such as performance into class problems using some techniques on the clustering method to implement the clustering based discriminant as CDA models to obtain the problem on this system. Parametric and non-parametric, both the clusters are handled in the system from face database and handled feasibility widely on the CDA models using efficient classification techniques such as K-NN classification to detect the person to match the input eye image. The observations can be projected on the subspace resulting information available. The use of generalized hyperbolic mixtures gives a robust framework capable of dealing with skewed clusters. Although the dimension reduction is increasingly in demand across many application areas, the authors are most familiar with biological applications, and so 2 of the 3 real data examples are within 3 space. Thus, that's where simulated data are also used for illustration. This is the flow chart of our process clustering based discriminant analysis for eye detection. This flow is important to reach the target of our process. In this flow, first of all, I give the input image is a eye image, and then the obtained input image to the wavelet transform. Importantly, we have to include the Haar wavelet transformation is very important, powerful technique transformation for CDA. Extract the CDA features. The CDA feature is nothing but cluster based discriminant analysis. This cluster based discriminant analysis is to be obtain the input as eye image. The pre-processing is one of the process which helps to prepare the images for our proposed work. In process, the input phase to be pre-processed such as grayscaled, filtered for the feature extraction process. Then feature values are extracted from the input phase for extract the corresponding features in phase of the input image. The wavelet transform is very useful and important domain transformation method in time to frequency transformation on the input pre-processed image. In this transformation, time should allow on transaction to change the values but not in shape. This transformation should not be obtained resolution different probabilities such as time frequency and scaling factor also is nothing but this model we have to transform our normalized input image effectively. The feature extraction process is very important to extract the features into using K-NN classifiers to detect the eye in our process of input the eye image. The feature extraction will help to identification process by reduce the complexity of classifier work. The feature extraction convert the image from the matrix to vector by extract the pixel information of the image. In proposed work we have the CDA feature extraction process by local binary pattern. This is the important model to CDA feature extraction process. In this process, compare those selected sets compared from the existing data sets, and then the final process is this should be the classification process of identify the person's eye to during the identification. In our process we have to turn the K-NN classification for extracted features from the input images as eye image, a stripped eye image. This step using the extract the features from the given images and then perform classified to the all images each by each in the database. This technique is very useful to identify the desired output from the existing dataset in this process. This is final process to detect the perfect person is a existing dataset. This is the MATLAB main window. In that main window we have to select the input files at the current place of current folder. This is the command window. Whenever you run any coding in our MATLAB, they execute on the command window. The workspace is nothing but storing the variables and functions and any values of your coding. This should be stored in the workspace. The command history is a history of using commands in our command window. Now we have to run the coding of our process. You select the file test.m in the current folder, right click the test.m, click the run. Now we have to select the window for to choose the which person or which image to strip the eye for our process. I select the fifth image, click open. Now I select the fifth image, and now I need to choose one value, the 1 to 8 for hard transformation of our process. I select the 4 and click OK. Now I have the images for hard transformation and also the stripped image to identify the which person in the dataset is to be detected. And then finally I have the output for green color shape of which person and which part of our detector, and then the eye are detected in the using clustering based discriminant analysis. Now we have to see the output images under one by one. This is the input image of our process. This is the input image of our process, and then I have to choose the next output in the stripped eye for our input image. This is the stripped eye image of our input image to viewing the eye image. Now using that stripped eye image, we have to extract the features using the hard transformation image. This is a hard transformation image, the level of 4 for pyramid. I choose the exactly from the previous window. This is the output image. The output image is nothing but which person I have to the input of our transformation of our process, and then feature extracted the CDA, the clustering based discriminant analysis to classify using the KNN classifier. From I have to finally give the output image, and then the final output is a detected face. The detected nothing but the detected face is using the MATLAB default function, and to choose the which part of I detected in that place. Thank you.